Okay, so what we're going to be talking about here is doing that review that was handed out in class. So hopefully you've tried all the problems before. You're just going to watch me solve them. I'm going to go pretty quickly, and then if you've got any questions, feel free to come in and get some help from me. Or to look at more videos on Khan Academy or geta5.com, where, you know, that is the same thing as when they have been, sorry, I can't seem to focus right now. They have the same video lessons, and they're going to call them either revolutions of solids or area between curves. It'll be something like that, okay? So we're going to start with number 1. I always like to draw a picture, right? So I am going to start by sketching the square root of x in this little space right here. So here we have this. Let me switch to a better color here, guys. Okay, so square root of x looks something like that. Oh, that's a good switch. Come on, green. Let's see if that worked. Awesome. And then x equals 4. Okay, so x equals 4 might look something like right here. Okay, so we're looking at this area of these two enclosed. So I'll kind of shade that in. And we're going to rotate this across the line y equals 4. So if I want to sketch in my axis or line of revolution, it's going to be up here. And I think before we actually try to make it visually see what's going on, I would definitely find a couple of things first, like the fact that we're going rotating it right here across a horizontal axis. I know for sure, guys, it's going to be dx problem because I had to draw a virtual horizontal axis, and therefore I need my x bounds. So I know it starts at 0, and right here I would need to figure out where it stops, which it told me with that line x equals 4. So that is for sure happening. Now, it's going to be a pi r squared cross section, but do I need pi r squared or do I need big R squared minus little r squared? Well, I'm going to need both because there is air in the picture. When this is rotating, there'll be a big old gap or space right there. So to find my big R, I need to go from the outside. So as this is spinning, this is the outside component. So I need to go from the outside to the axis of revolution. That is my big R. So I'm going to go, the way I'm going to write it is I'm going to go from 4 down to 0. So I could write 4 minus 0, or I could just write 4 squared. That would be that big outer R. My inner R, my little r, is the inside radius. So it's just going to be from the axis of rotation or revolution to the inside of the shape as it's spinning. And that would be just 4 minus the inner curve. Okay, 4 minus the inner curve. And that inner curve is the square root of x. So that's going in for my little r. Okay, now if you had done this one minus this one, that is okay. Over here you would probably have 0 minus 4. So if you switch these around, that's actually just fine. You could do top to bottom or bottom to top. And they're inside a squared, so it's going to work out in the end. Okay, and so that's it. It just says write the integral that represents the volume. So it'll be pi from 0 to 4, integral from 0 to 4 of all this. Okay, and that would be your answer. All right, number 2, find the area of the region enclosed by the graphs of y equals x squared plus 2, something like that, and then y equals negative x squared plus 10. Okay, so 10 we're just going to say is way up here, and now we're doing a parabola that goes down. Okay, so I need to find area of this, which means I definitely have a top and a bottom. So I can do top equation minus bottom, but I'm going to need my bounds. So for top minus bottom, the one that's on top is this one, minus the one on bottom is this one. And I don't need anything squared, or I don't need a pi, because this is not volume, okay? It's area. I just need to know my bounds. So to find my bounds, I'm just going to take my two equations and set them equal to each other. And so when I solve that out, I'm going to get 2x squared equals 8, x squared equals 4, plus or minus 2. That'll do. Hopefully that makes sense right there. You just set them equal, solve for x, and those are your lower bounds. So there's my -2, there's my +2, and that's going to give you the entire area. It doesn't say to solve. Oh, yes, it does. Dang it. Okay, find the area of the region. From here, if it's a calculator, you could just do Math 9. If it's not a calculator, I guess you would need to, what would I do? I guess I would go ahead and combine these and have a -2x squared and then +8, and I would integrate, and then plug in my top and bottom bounds. So if you want to do it by hand, guys, you're looking at x cubed -2, x cubed over 3 plus 8x, and you're doing that from 2 to -2, and you plug it all in, and then you'll get your answer. I don't know the actual answer. I don't have a calculator, but that's what you would do. Okay, number 3. A solid has its base in the xy plane bounded by the x-axis, okay, the y-axis, and the function 3 minus x to the 4th. Okay, 3 minus x to the 4th is going to look something like this. And it doesn't say which side that we're on, whether it's the first quadrant or the second, but honestly, since it's symmetrical, it really doesn't matter. So I'm just going to choose the first quadrant to bound between here and the curve. And we're going to do cross sections perpendicular to the y-axis. So we mentioned in class, whatever you are perpendicular to, that is going to be what you integrate with respect to. And what this means is that I'm going to be laying my semicircles this way. So if you already knew that the semicircle formula was pi over 8 s squared, that's really great. Now we just got to fill in what that is and what our bounds are. So if these are y's, I need my bounds to be y's. So it looks like the lowest y on my paper is 0, and the highest y on my paper is going to be 3, and that's just from knowing the graph. S is going to be this distance right to left. Once again, something we've kind of talked about the end of this week, right minus left. So it's going to be curve minus 0. Curve minus 0. And the curve is the equation y equals 3 minus x to the 4th, but I really need this in terms of y. So I'm going to rearrange this. And I need the x by itself, so I'm going to take the 4th root of that. So this is how I could express my function. So it's just going to be pi over 8, integral from 0 to 3. These are the y bounds. And I need to take this, this curve minus 0, and then I need to square it because we're doing a cross-section formula. So it's the 4th root of all of this and then squared. And it does say to actually find the volume of the solid. So from here, I would do Math 9 in the calculator and get all that typed in, and you will be good to go. Okay, number 4, let R be the region in the first quadrant. Okay, that's good to know. First quadrant, bounded by y equals 4 minus x squared. So up 4 and then a negative x cubed. So it's going to look something like that. The x-axis and the y-axis. Okay, so we're just looking at this little piece right here. And what are we doing to this? Okay, we want to take a vertical line and cut this region into 2 smaller regions whose areas are equal. So what this means is somewhere in here is a vertical line that they're saying to call K. So I'll draw it in there. I have this K that's going to cut this in half. So I'm trying to figure out where K is. So what I would do is view this as find the area of the whole green piece and cut it in half. And then we'll set that equal to some other integral where our bound has to do with K. Okay, so how do we find the area of the whole green piece? Well, the first thing that you would do is just top minus bottom, which is the curve, minus 0. And we would do that over the x bounds of 0 to question mark. We got to figure out where this hits the axis because we're doing x's now. And so let's see, if I plug in a 0 for y and solve, it looks like it's going to be the cubed root of 4. And that's just doing a little bit of algebra. If you have a calculator, feel free to look at that on a calculator and actually write that decimal up there. And we're going to do the area of this, okay? So once you actually crank through this and you get some sort of a number, that's the area of the whole piece. So I need to take this and cut it in half, because what I'm looking for is how to find k using half the area, or the fact that it's going to create half the area. So once you get this number, you can just set it equal to just this part of the picture right here. So you only have to consider 1/2 of the total picture now. So I'm going to say, well, this is equal to the same top minus bottom, okay? But now instead of going all the way from 0 to this point, I just need to go from 0 to k. And that is going to be how I do this problem. Now, once again, I don't have a calculator, so I'm actually going to take just a minute and try to find this and start doing some algebra. So let me go ahead and approximate that. Okay, so what I've done here is I have just, I've actually done this part in the calculator, and I get this value. Over here, I'm integrating by hand. So I've got 4x minus x to the 4th over 4, and I need to go from k to 0. And the reason I'm doing this is because this part you can't do in the calculator. You're going to have to do this by hand so that you can then do some algebra. So I'm going to keep my 2.3811 here. I'm going to plug in my k, 4k minus k to the 4th over 4, minus, I'm going to plug in my 0. So that's going to be 4 times 0 minus 0 over 4. Okay, this is the equation I'm trying to solve for k. Well, all this is gone. So here is my actual equation. I'm going to pick up a calculator, type this in y1, and type this side into y2, because if I can look at a graph, I can just find where they intersect. And wherever they intersect, that's going to be my k. Alright, so for the last problem, I'm still recording. Okay, so for the last problem, guys, all that you have to do is, it's going to guide you through the whole thing of drawing a picture and blah, blah, blah. First thing is you might want to actually look at it, right? So look at your cosine x and your x squared, and it says to find the points of intersection, okay? So this should just be a look on the calculator and actually look for second math or second calc 5 inner stuff. And then we'll lay out this. Okay, so once you actually do that in the calculator, these are the points that you're going to get. And it is symmetrical picture, so it makes sense that the points are like that. And now for part B, it wants us to find the area of the region bounded. Well, if you look at your picture, the cosine curve is the one that's on top, and the x squared curve is bounding below. So we'll just do top minus bottom. I'll do a dx right here. And since everything's laying out nicely as top minus bottom, it's in terms of x, this is a dx, I now need the x's on my bounds. So this will be a 0.8241, and I need the -1 down here, okay? And then the +1 up here. You always want to go smallest to greatest, or left to right, okay? So that'll be it. So it's just going to be Math 9, typing those in, and we will see what we get. And I just got 1.0948. So assuming I did it correctly, hopefully we all get that same answer. For part C, the region R is the base of a solid. And what's happening here is, if you kind of focus on that, just that one little piece of the picture, it's going to look something like this, right? Okay, so we're looking at like right here. Okay, so on that piece of the picture, each cross-section of the solid is parallel to the y-axis. Okay, parallel to the y-axis means perpendicular to the x-axis, and that's important to know because whatever you're perpendicular to is going to be what you integrate with respect to. And we're doing rectangles, so volume of a cross-section is equal to the area formula, the integral of the area. And for a rectangle, that's just length times width. So I've just got to figure out what to fill in for length times width. This one says that the shorter side lies inside the base, so the short side of the rectangle is just top minus bottom. That could be my width, okay? And then it says that the longer side is twice the width. So based on that, if this is twice that amount, then I know I'm going to be multiplying this by 2 more of these. So I'm just going to call that squared, since that whole thing is getting multiplied by itself, and then I'll have this 2 on the outside. That's going to be the formula. That's going to be what you type in. We're still doing with respect to x, so negative 0.8241, 0.8241, and we're just going to do math 9 on that and get an actual number for volume, and that should be it.